Hello students, we are continuing to talk about ways to prove two triangles are congruent using deductive reasoning and proofs. Today we're going to talk about angle-angle side triangle congruence. Just reminding us what we're doing, we're pushing our brains to think in a new way called deductive reasoning. And it's a type of thinking that's really precise and really rigorous. You have to come up with a reason for everything that you state, and you have to make sure that those reasons are true. So let's take a look at this. Whenever you see a figure, the first thing we want to do is say, what do we see? I see triangle ABC. Okay, what else do we see? I see line segment AC is marked. Do we know what kind of triangle it is? All three angles are acute. This is an acute triangle. Do we know about how to classify it by its sides? Well, if this angle and this angle are different, I know that this side is different. So it looks scalene to me. All three sides look different. I'm going to be a little lazy. And so we can classify it both ways. It's not as important. What else? Oh, we have two angles that are marked. Okay, so angle A is marked, and angle B is marked, and side AC is marked. What's the relationship between those three? Is the side in between included between the two angles? No, it's not. If we had this side marked, it would be included, but we don't. We have this side over here, which is not next to both of, it's next to angle A, but it's not next to both angles. So when I look at this figure, I say, oh, I have an angle marked, and a side marked. So we call this angle, angle, side. It's different than angle, side, angle. Okay, if it was like this, angle, side, angle, see how this side is included? We would call that angle, side, angle. This one is called angle, angle, side. Could I call it side, angle, angle? Yeah, but we put angles first. Maybe because it's alphabetical. Maybe because triangles have three angles, so angles are more important. I don't know. All right, let's go for it. So we want to keep going back and thinking about what we have two definitions of congruence, really. We have these new ones where we're looking at the parts of the triangle, and we're seeing if we can get enough parts that match up, it means the whole triangle is congruent. The older definition we have is that if we can map one onto the other, then the triangles are congruent. So is there a mapping that would take triangle ABC onto triangle DEF? Yeah, and this one, I could just take triangle ABC, and I could say it looks like the same size as triangle DEF. And in this situation, it looks like it's a straight translation. I can move it over some and down some. I don't think I even need to rotate it. So this is just going to be a straight translation, and I'm going to move it. I don't know how much. If I put it on a coordinate plane, maybe I'll just go like that. Let's say this is 1 and this is 1, 2, 3, 4. Yeah, I'm just kind of being a little lazy here, but we could say I'm going to move it over 4 and I'm going to move it down 1. Okay, or if we don't have a coordinate plane, we can say that we can move it so that point A would map onto point D. So we're going to move it until A matches up on D. I'm not sure about this notation, but remember we use those pointy angle brackets if we're talking about the vector. We're moving it from A to D. It goes right 4 and down 1. Okay, that's fun. Now we'll do it the traditional way. So we have a figure, which we're going to copy. We have our given information. We have what we're trying to prove. Okay, over here goes statements. And on this side, we write our reasons. And what's given? We're given the figure as marked. And what are we trying to prove? The same thing we've been trying to prove this whole time, which is that two triangles are congruent. Triangle FGH is congruent to triangle JKL. This one's nice because they're oriented the same way, so I can just read it off from these three and these three. They're also alphabetical, which we know is super nice, but doesn't always happen. Sometimes we have to think a little bit harder. Okay, you should be getting more comfortable with these. So let's just pick it up. And this lesson is angle, angle, side. So that's the order I'm going to list them in. Angle F has the same mark as angle J. It's given to me because they have the same mark. Angle G is congruent to angle K. How do I know that? Angle G has two little marks. Angle K has two little marks. That is also given. Line segment FH has the same mark as line segment KL, but it's not included, right? I didn't list that second because if it was included, it would be FG and JK, but the marking is on line segment GH, and that matches up very nicely with line segment KL. That is also given. All right. I'm done. Triangle FGH is the same size and shape as triangle JKL. And the reason I know is because I've showed you a pair of angles match up, I've showed you another pair of angles match up, and I show you a side matches up. So that is called angle, angle, side, triangle theorem. Here is a more fun one. This will be fun. This is on your worksheet tonight. Let's see if we can take it step by step. I'm stalling, so I'm gonna write the statements and reasons, set up my paper, set up my thinking about what I have to do. I know my last statement is gonna be what I'm trying to prove. Okay, I know I got a whole bunch of stuff written here, and I'm gonna stop and stare at this picture. So the first thing my brain sees is right angles. I also see this looks like a rectangle to me. I see two triangles. I see triangle ABC, and I see triangle CDA. And if I was trying to map this one onto this one, I would probably rotate it. Maybe I'd rotate it down, and then it would look like this. I was working with some people, and I said sometimes it's easier if you kind of spin it so that they're right next to each other. Makes it a little easier. So this would be B, this would be C out here, and this would be, did I do that right? Yeah, this would be A up here. Sometimes you want them in the same orientation. Okay, what else do we see? We say angle B and angle D are right angles. Okay. So if I'm starting to stare at this and think of my plan, I know that I have a pair of angles that are congruent. So that's going to go somewhere in my proof. Angle B and angle D have the same mark. They're both right angles. So there was that statement from yesterday, right angles are congruent. Okay, what else do I have in this picture? I see they're stuck together. Do you guys remember that one? Are we allowed to say that from C to A on this triangle matches A to C on this triangle? Yep. So I don't, how did I say it? I think I'll say from AC, and I'm also looking here, AC matches up with CA. So I use the first and last letter, so I'm going to use the first and last letter. If that's a little confusing, it's okay. Okay, those match up. I'm going to even just mark that. Okay. What else do I need? I'm trying to prove the triangles are congruent. I have a pair of angles and a pair of sides. And what other given information do I have? I have line segment BC is parallel to line segment AD. I don't have the same marks on these. Even if you think these are the same length, we don't know that for sure. You would have to give me some reasons why you think that's true. Okay, you might even think AB and CD are the same, but we don't actually have a reason. We haven't done any work with rectangles yet. So if you say because it's a rectangle, I'll say, no, I don't know anything about rectangles yet. We haven't learned that yet. I don't understand. I don't know what a rectangle is. We haven't even defined that yet in our course. So we can only use reasons that we've already talked about and agreed upon as a class. We have to have the same set of facts that we're drawing from. Okay, which is part of the problem with our political stuff right now. All right, get off my soapbox. Where were we? I'm stalling. Okay, so we have these arrows right here, and the arrows mean that the lines are parallel. So we know they're parallel. Can we think back? Can we remember the stuff that we learned about parallel lines? I'm going to draw it so that it looks like what we did in topic 2. And this is where everything comes together. You got a midterm coming up. Everything has to come together now. So we have parallel lines. Do you remember what this line is called? Whoa, very wiggly. Yeah, that's a transversal. Okay. So this is a parallel lines cut by a transversal. And my question is, is there a way to show that another angle on this triangle matches up with another angle? Just playing with the figure, staring at it, trying to take the words that I know and think back in my mind. How is that angle related to that angle? I'm just gonna number them because I'm a little lazy. So do we have words for angle 1 and angle 2? Do we have a vocabulary word that we're gonna be able to use? They look like the same size and shape to me. I think that they are, but I need to come up with a reason why that's true. All right, let's try this proof. You guys can keep thinking about that reason. So the first statement I'm gonna do is, yeah, I'll do angle, and I need to write a little smaller. Not sure how many steps this is, but I have quite a few things to fit in here. So angle B and angle D are right angles. Okay, that I read right here, angle B and angle D are right angles. So that's given to me. And what follows from that is that angle B is congruent to angle D. I'm just gonna follow that right up. So I have my first pair of angles. Okay, and how did I know that? That's the theorem that says all right angles are congruent. Can anyone find what page that is in the textbook? I don't know. I think it was probably in the first chapter, first topic. Okay, and no, we didn't talk about that in class, but now you know. Okay, now what? Should I do this side next, or should I keep that for later? I think I'm gonna keep that for later. Okay, I used that. I'm gonna keep this side for later because I want my proof to flow angle, angle, side for whoever's reading it. Then my my final reason is stronger because someone can just look back, oh yeah, there's the pair of angles, there's the pair of sides, oops, there's the other pair of angles, there's the pair of sides. Okay. So let's go for that next part. So we took this piece of given information. Now we're going to take this piece of given information. So it said line segment BC is parallel to line segment AD. Okay, that was given to me. Huh. All right, let's see if you got it. I think because they're parallel, that angle 1 is congruent to angle 2. And you guys come up with the word why that has to be true, that the statement that links parallel lines to these angles? Good. If the lines are parallel, which they are, we are allowed to say that alternate interior, maybe I'll write that out. Alternate interior angles, which 1 and 2 are, they're both in between these parallel lines, and they're on alternate sides of the transversal. One's on the top, one's on the bottom of the transversal. Alternate interior angles are congruent. Cool. And if someone doesn't believe you, you can go back to that topic and show them in the book, hey, this is what alternate interior angles look like. You cannot argue with me, that is true. All right, we've showed a pair of angles. We showed another pair of angles, one on each triangle are congruent. Now what? Good, we need our sides. So I have it up here. I had line segment AC. Matches up, is congruent to line segment CA. And that is because, you remember, are you getting used to this one? They're stuck together, they're the same. This is called the reflexive property. This is a popular one when we're doing triangle stuff. So I showed a pair of angles, another pair of angles, and a side not included. So I am done. Triangle ABC is congruent to triangle CDA. No one can argue with me. I've given evidence for all of my claims that I've put forth in my statements. So, and I've used a property that's allowed, which is angle angle side triangle theorem. I misspoke. I used a theorem that is allowed. Okay, there's the theorem in the book. That's why we can use it. It says if two angles and a non-included side of one triangle match up with two angles and a non-included side of the other triangle, then the triangles are congruent. Okay, be good, work hard, keep learning. Bye.